Okay, in this final lesson, in this particular section, we're going to talk about how to fix problems that occur in Kolor Autopano. And more importantly, we're going to understand a little bit more about how the thing works. Because the better you understand it, the better you can understand why it doesn't always work. Okay, so if we look here at the file that we made the other day, we can see that we have some obvious mistakes. We have basically two halves of the spaceship kind of mashed together. And we've got this huge boulder that looks, anything that's spherical, it looks like it's been cut in half. And the reason is because basically these are errors in the stitching. The computer is looking at more than one camera and it's trying to align them as well as it can. And the fact that it can get this close is actually pretty good. And so what we're going to do is we're going to help it along by understanding a little bit more about how it does this. Okay, so here we are with our original 6 videos. And we're just going to go through that process once again and demonstrate how we can optimize it a little bit better. And as often happens, Kolor Autopano has a new version available. And that is this one here under this little purple icon here. It's the same program except it's Kolor Autopano Video 3. And it works pretty much exactly the same way. And as you can see there, it is loading up once again. And again, this is a drag and drop environment. Absolutely nothing obvious has changed. And if we go here, we're going to take our 6 videos, which are the 6 camera positions, and we're going to just drop them right into that interface. And once it's done that, it's going to give us this. Now remember, these are the 6 views that it's going to put together into a sphere. So the camera rig gave us 6 different positions that looked off in 6 different directions, and so this would be where the user would appear to be. And so the idea is that these individual cameras would record those sections of the viewpoint, and then they'd be mapped into a spherical screen. So you can imagine the user is now standing inside a ball looking at different viewpoints provided by these cameras. And so if the viewpoints are perfectly synchronous, it will look like there is only one large viewpoint. And that is very difficult to do. And I don't think we could really do it very easily without a computer. Okay, and here again, if you look at this section of Kolor Autopano, really the controls start here. Synchro would be the thing we would normally do first to make sure that all of the videos were synchronized at the right point in the timeline. But in this case, we really don't have to because they are identical by the very nature. We basically created 1,000 frames from each viewpoint, and they were perfectly synchronous. This would be used if you were doing it with the actual rig and you were shooting videos with the GoPro cameras. Stitch is where we start really doing the important work. And so here, this whole thing is based on GoPro cameras, and so we leave that one alone. And down here, we choose the current selection instead of the current position, which will mean it will take 5 samples throughout the video. And then we basically just hit stitch. And that will take a few seconds. And when that is done, you get this little window over here. And of course, we can move these windows over a little bit because we don't really need to see these anymore. And so this is what it's created so far. And if we double click on this, we can see there it is. And we can already see some of those errors. And so if we drag and pull this scene, the first thing that we want to do once again is to establish the horizon. And we can already see the errors that we have to work with. Basically, the ship is positioned twice. We can see there's too much of it there. Now the fact that it looks arced is not the problem, because that will not look that way when you look at it with the goggles. When you're looking at it with the Google Cardboard system, that will actually look straight, because we're looking at this from a spherical perspective. On the other hand, you will see that there's 2 ships. The same thing down here with the ball. We can see that the ball is cut, and so we don't want that. But in any case, at this point, we just double click on this and we apply the horizon. So you hit the apply button and that will light up that for a second, which will get all that taken care of. And then we're going to move on to editing those control points. Now the control points are the positions that the computer uses to merge these various files together. It does this by an algorithm that tries to find things that are common to specific files, which is actually quite amazing when you think of it. So I'm going to hit the Edit button here. That will open up a second program window, which is called Autopano Giga, which is a sort of like a companion program, and that allows you to edit those control points. And if we double click on this image, then we get this map here where it shows you a grid pattern. And basically what we want to do first is look at the major issues with the control points. But before we do that, if we go to this button here called Mask, if I go around here, you can see what those actual viewpoints look like. These don't look at all like the original frames would, obviously. They're stretched into all kinds of ridiculous shapes to get this stitching done. So again, the fact that it looks normal when you look at it is pretty amazing. So what we're going to do is we're going to edit the control points themselves, which we'll do by hitting this button here. And that gives us these two empty windows. Now over here on this side, we have a little column for each camera. So for example, if I hit camera 6, I will see a window that shows camera 6 there. And if I go down to this window here, I have 4 possible choices. 6.1 shows camera 6 and where it intersects with camera 1. So the computer felt that these points here, these little bitty tiny points, corresponded to these particular points here. And I don't know if they did or not, but they seem to have been pretty close. And the same thing with this viewpoint, and this viewpoint, and this viewpoint. Not all that useful. If we go to camera 5, here we may be getting somewhere. And 5.1 shows this viewpoint with that viewpoint. 5.2 shows that with that. And 5.4, this is the one we're interested in. Because notice how the ship has not been selected at all for control points. The computer was off over here in the sky looking at those clouds. And so this has not been given very much attention, which is why it didn't work. So what we want to do is we want to tell the computer that this is important. So this part of the ship here, from that to that, seems to be represented over here. We don't get the front of the ship though, the entire front of the ship. So what we're going to do is we're going to concentrate on what we do have. So I'm going to draw a box around the part of the ship that we can see is common in both images. And then I'm going to match that over here. So that will include all of that. And what the computer will do is create control points. And I'm going to do that a couple of times. And it will add some more. And maybe one more time. So the computer is now being trained to recognize that ship as important. Now notice the control points are red. That means that the computer isn't sure of them. So what we want to do is we want to encourage the computer to think about those points. And so if we look up here, there's this button called Quick Optimization. I'm going to click that and the computer will sort itself out. So now some of those are green, others are different colors, but that's getting closer. And so while we're also here, let's look at camera 4 and camera 4. You can see this is the point where camera 4 is lined up with that ball. Now the ball obviously is not correct yet, and it's got some points there, but apparently not enough. So what we want to do is we want to help the computer know what this is. So I'm going to draw a box around this lower half of the ball, which includes part of that ramp and part of the platform there. And I'm going to try to find roughly the same area over here. We'll just add some points there as well. So that way the computer can figure it out, maybe one more pass. And I'm going to hit optimize there. And let's see what it does. Okay, so now that that's done, let's see how far we got. So if I close this window, you'll see that if you look at it from here, now the spaceship is complete. It's not perfect, but it's getting there. At least we don't see the rings repeating, and the ball even looks a little better. And so what we can even do is close this out altogether. Close this program out and save it and see what it does here. You'll notice the picture updates. And so if we look there, it's looking a lot better. It really is. It's still got a little bit of problem there though. So let's go ahead and hit edit again. We'll reopen Giga. Double click on this again. If I open my control points, and I go back to this window, you'll see we have a few other windows that we can look at. And I'm going to turn on preview just to make sure that we can see the changes as they happen. And there are a few tabs here. Now we're going to focus on this one here because it does a lot for the amount of time it takes to do it. Where it says distortion, we're just going to go ahead and optimize first and second and third quarter, which a lot of the people that use this program don't even necessarily know what those mean. But what that will do is it will kind of smooth out some of those transitions and give it another look. And so if I go to my optimization tool, full optimization, let's see what that does. I can see it did something there. And if we were to save this by closing this out, we go back to here, that's become a whole lot better. Now we still have a little bit of a problem there, but most of it is actually pretty good. And we can keep playing with this, but let's look at what this looks like so far. So if I hit the render button, and I get this dialog box here, and once again we want to use a slightly lower resolution than possible, only because we want to see what this looks like on your average cell phone. And some of them are getting better, but we want to make sure it plays. Now the other problem that we have with this system is that it's made by people in Europe, and so they have chosen the PAL format as the standard. So we're going to switch that over to NTSC, which is the television format used in America. And we're also going to set the frame rate at 60, which is really 59 and change. And then all we really have to do is choose a path for the file. I'm going to put it in there with the videos, and I'm going to call that stitch underscore final. And then I'm going to hit the render button. And this is probably the only thing I've seen change in the Autopano program. They've given you basically a render queue, and you can see it working on the render. So here you can see, if you look at the video, that the spaceship is now pretty much under control. You can see that the spaceship is not repeated. You can also see that the ball is almost spherical, and if you weren't looking closely you might not notice that, but of course you could fine-tune it even more if you really wanted to. But that's basically about as good as we have to get it for this exercise, just to demonstrate what's possible. So this is correcting stitching errors using Kolor Autopano Video and Giga.